So good morning or good afternoon to those of you joining this Megaport Tech Drop-In session. My name is Mike, and I'll be walking you through Megaport and look forward to answering any questions that you have along the way, so feel free. I'm sharing my desktop now. I'm going to go over a few slides just to set the stage for what Megaport is and what we do. And then we're going to do a little whiteboarding or some diagrams of some actual customer scenarios. Hopefully that'll sort of jar your thinking into different ways we can approach your network and some solutions you may be considering. And then I'm going to do a quick portal demo, and then we'll wrap up. So with that in mind, Megaport, what is Megaport and who are we? Well, we're based in Australia. We've been around for about 10 years, and we are a network as a service provider, which is to say we help companies easily scale their WAN environment to connect to data centers, to connect to the cloud, to connect to other customers. And we do that in a few different ways. And I'm a solutions architect for Megaport, and I've been here about a year and a half. And I can tell you, it's an exciting place to work when you see how easy and quickly we can stand things up. It becomes contagious, and hopefully we can communicate some of that today. So, increasingly the infrastructure of the enterprise is diversified. 77% of Megaport connections terminate to public cloud providers, and 43% of them connect to multiple cloud providers. And we'll talk about the hybrid cloud here in a little bit, okay? So hybrid cloud is the idea that you can get to multiple clouds, whether it's AWS, Azure, Google, or Oracle among the top ones. And you can connect that through something we call a Megaport or a port, which is a physical router, physical device that lives in a data center that you connect to with an Ethernet interface over optics. And that can be within the data center itself, or it can be with a last mile connection. And one question that comes up quite a bit is, hey, Megaport, do you provide a last mile connection? And the answer is no, we don't. We work with providers that you bring into the data center. Very common ones are, Lumen or Zayo, among others. And you get that last mile connection, you terminate it into a port, and then you connect it with what you're seeing on the screen via a VXC. And we'll talk more about that too, but that's a layer 2 construct, a layer 2 VLAN. All right. Cross cloud is the idea of deploying a virtual router. What you're seeing on the screen, the MCR, is a Megaport cloud router. And the idea of a Megaport cloud router is to move between clouds, move workloads, and stay local to those regions whenever you can without having to bring that workload back to a data center. So what you're seeing on the screen here shows that perhaps I maybe need to move workloads from Azure to Google or vice versa. And I can do that through the MCR. It is a BGP peer connecting those two, and it allows me to localize and regionalize that. And again, we'll talk about that here in a bit, but it's designed to move cloud to cloud. We jokingly refer to it sometimes as my first router, and it does have some very strong capabilities, but it is intended to be a fairly basic BGP peer. Okay. Virtual POP is extending a construct of the Megaport virtual router and what we call Megaport Virtual Edge, which you can take a SD-WAN, a router, or a firewall license and install it on compute within the Megaport infrastructure, which I'll show you in a bit on a map. But we have endpoints around the country that host both MCR and MVE in virtual computing environments. And in this case, you stand up a license of a Cisco, a Palo, a Fortinet in our infrastructure and connect to it via IPsec tunnels. And then you can connect to the cloud to other Megaport resources that, like you're seeing here, colo and data centers, also Azure, AWS, Google. Global WAN as a service is something we're really seeing a lot more traction, especially recently, where customers are trying to decouple disparate MPLS networks and get global reach using a Megaport backbone to get from different regions. So I can go from Dallas and I can go to Ashburn, or I can go across the Megaport backbone all the way to Singapore or Amsterdam or Frankfurt. And I can localize that traffic with a Megaport cloud router within those regions and isolate my clouds there. And I'll talk to you a little bit more about that coming up as well. So let's sort of take a step back, and I went through, the different scenarios, but where they fall in with what we refer to of our infrastructure. So the port, as I mentioned, comes in 3 different speeds. 110 and 100 gig, we're actually deprecating the 1 gig, so they're not available to new customers, except in specific use cases. We primarily focus on 10 and 100 gig. The 10 gig ports are the same as the 1 gig ports, pardon me, are the same as the 10 gig. And that's that physical device that lives in a data center that I was referring to. The Megaport Cloud Router, again, is that virtual construct to get me between cloud regions. And the Megaport Virtual Edge is extending that virtual concept to, again, SD-WAN, router, and firewall. VXC is a virtual cross-connect. The Megaport Marketplace will be a little more clear in our portal, but the Megaport Marketplace is where you can connect to people who services such as Cloudflare or Wasabi or RingCentral, and they have Megaports in their environment, and you can stand up a connection to them with a virtual cross connect, typically from a service key, which is an encrypted key that you can use to connect to them, and I'll walk you through that as well. Mega IX is our internet exchange offering, and we're in major POPs all around the globe for those close peering relationships that you may be interested in. And Megaport Internet is actually a fairly new product where you can actually stand up a connection to the internet from a port, an MCR, or an MVE. So I kind of alluded to this, but again, it's a physical cross connect in a data center that can connect to all these various attributes that we just described. Cloud router, we touched on, no hardware needed, supporting your multi-cloud, making networking easier. Megaport Virtual Edge, these are the vendors that I was alluding to that you can install this license on a compute in one of our data centers around the country. And you can combine that with internet transit, which I'll get to when I show you a slide here in a bit. And that allows you to connect via IPsec and connect branch offices and remote site locations to your infrastructure without the need of a last mile. And this is what that looks like. The MVE comes in several different sizes, depending on the number of cores or CPUs you need, as well as the amount of RAM. And you can see that it's 2, 4, 8, and 12 CPUs and RAM extending from 8 to 48 gig. And then you can also have internet transit associated with that. Think of this as where the IPsec traffic would terminate to, and that can be in increments from 20 up to 10 gigabits. Virtual Cross Connect, again, is that layer 2 construct. It is a VLAN, and they are anywhere from 20 to 10 gig, 20 meg to 10 gig, and can be scaled on demand on our platform. And then in certain cases, they can be scaled up with cloud service providers, okay? So with that in mind, I sort of laid the groundwork with what these particular products do, but I want to show you just some examples of what those look like in the real world based on some customer examples, okay? So the first is the port that we've been alluding to. This particular branch office here is connected to a Megaport location, in this case, CH4, via a last mile connection to a physical port. From there, we're connecting to an Azure cloud, and we've done this in an interesting fashion. The Megaport itself is a single instance deployment. So if we ever perform a maintenance on a particular router, it will take it out of service. And so we often recommend that customers deploy a secondary router within the same location or a different location, and what we call red and blue zones, and we'll never perform a maintenance on the red and blue zone at the same time. So by having this, a different connection to these ports, I can actually maintain my uptime in the event of an outage, but also have diversity as it extends to connecting to a cloud. Azure, as it turns out, likes to have the ability to, or offers the ability through their SLA to have diverse VXCs. So you need 2 VXCs to diverse Azure routers to satisfy that, both a red and a blue. And I'll show you this in the portal. From this diagram, what we've got is diverse ports, and then we've got one express route divided with service keys into a red and a blue to diverse routers on the Azure side. So this isn't required. I could run a red and a blue off of a single port, but if you wanted to get around the maintenance piece, that's something we could take into consideration when we're doing a design, all right? Now this scenario links together a port and an MCR. Now the MCR, you would want to isolate your closest to your cloud region. Let's say, for example, that I was in the central region, I could make sure that I could communicate between Azure and AWS, going back to my Megaport cloud router and not having to hairpin all the way back to a data center. This becomes also useful if maybe I decided I wanted to stage an MCR and put that virtual compute close to my workload region, and maybe it's in the East region. So I stand it up in Ashburn as an example, and I could isolate my East region traffic from AWS and never have to bring it all the way back to my data center in Chicago. But in this example, we are giving you the option to connect the Megaport to the Megaport Cloud Router and extend that connectivity singly or diversely from AWS to Azure. Now, MVE, again, is leveraging IPsec tunnels from branch offices so that I don't have the need for a last mile connection like I showed you here. So as I mentioned before with a port, a customer may have racks in a data center like Equinix, or they may be extending from a branch office via Zayo or Lumen. The concept of the MVE, again, is a virtual compute. Think of football cities around the United States, and we have several locations per city. And as example, in Chicago, we have 5 different locations that house MVE and both red and blue zones, but I could stand up MVE in diverse locations in Chicago as well. But in this scenario, I have branch offices that are connecting to the internet over IPsec tunnel and then grabbing internet transit from Megaport to get to their MVE. So when you order a Megaport MVE, it has the size of the MVE that I alluded to before, the cores and the CPUs, and then it also has the internet transit associated with it. And then you can build the VXCs to get to your cloud location. This was also a fairly typical scenario. In this case, I'm showing offices that may be coming from the East Coast, or it may be coming from the central US. They get their internet transit. They land on, for example, a Palo license MVE. And then so there's potentially branch offices with a firewall here. And that just is extending that branch footprint to the virtual compute in Chicago or Ashburn in this case. Okay. Now, global WAN, this is actually an interesting scenario of an existing customer that had disparate MPLS networks and a worldwide footprint, including Canada and the United States, and 2 offices within, or excuse me, 2 locations within the US, in Denver and in the East Coast. And what they actually did was extend their rack footprint to data centers in Denver in a dual fashion. So there's dual ports, they have dual racks. They get a cross connect from the data center provider and connect to the Megaport. And then what they did was created diverse ports in DC, in Toronto, and in London, and they cross connected all of those sites together with the virtual cross connector VXC. So this is a fully meshed configuration that allows any resource, whether it's Toronto, London, DC, or Denver, to talk to each other via the virtual cross connect. But also each one of these sites has the ability to talk to Google Cloud and a redundant configuration as well. So we've got diversity from red and blue and Google, diverse ports, and diverse VXCs. So this is, again, one of the emerging trends we're seeing is the global WAN. I can get rid of different MPLS providers, and what we've also seen customers do is they, if they have revenue obligations with a carrier and they're taking down their MPLS footprint, they actually move that revenue over, add a last mile connection to a Megaport data center, but then use our VXCs to mesh as opposed to trying to combine VXCs together or MPLS networks together. So I hope that's clear. So with that in mind, I want to talk through the Megaport enabled locations. So this is within the United States. We have over 800 points of presence around the world, and we are data center agnostic, which is a huge point. We're in Digital Realty, we're in Equinix, we're in CoreSite. So we're not beholden to any one data center provider, which is a huge value add for Megaport. And with that in mind, these are the US locations that I'm showing here. And when I talk about MCR and that virtual compute, you'll notice if I sort, this is those NFL cities that I was referring to. And if I hone in on Chicago, I can actually see that I've got 5 different locations that house the MCR compute. And there's Digital Realty and Equinix and CoreSite, just in some of these examples here. And the MCR lives on a 6-WIN platform. The virtual router lives there, and it sits on top of Cisco servers. And that allows me to create that MCR that I'll show you in the portal here in a little bit. But I have redundancy within Equinix CH4. I have the red and blue zone that I was pointing out. And then I also have diverse sites. So if I could maybe put one in CH4, and maybe I put another one in Digital Realty, and that gives me building diversity, geographic diversity, as well as zone diversity, right? So that's the MCR. I'm going to highlight the MVE, and you're going to notice it's basically the identical footprint. All right. The MVE lives in the same locations around the country and diversity, just like what I was showing you in Chicago. And the MVE is a Cisco 8000 V, or 8KV is what we refer to it internally. So I can stand up my MVE, select the number of cores and CPUs that I need, and order my internet transit to connect to it. So I hope that's a good explanation of where we live. I'm going to back out and just show you where we are from a global footprint. You can see we've got a tremendous density worldwide, and we can get you to over 800 data centers, as I was saying before. So pretty neat in terms of our footprint. And so with that in mind, what I'm going to do is bring on the Megaport portal. One of the things that we really pride ourselves on is the ability to stand up a connection very, very quickly. And this is a services dashboard. This is actually a lab environment that the essays use quite a bit. And you'll see that you can, if this was an existing customer environment, you would see your ports, MCRs, MVEs. You could see, you can hone in on a specific site where you have services built, and you can see that you have a port that's built in core site Denver. And that's actually the company I'm going to show you here in a little bit. And it's a 10 gig port, no VXCs attached to it right now. So let me navigate into this screen right here called the Services tab. And the Services tab allows me to provision 3 of the services I've been talking about: a port, an MCR, or an MVE. So in this particular example, I've already got a test port provisioned in DataBank and in LA. And what I want to do is actually see if I can create a diverse port. This one's in the red, but I decided, you know, I want to have the ability to have an additional port created. So I'm going to go and create a port. And we're going to grab DataBank LAX1. And we're going to select a 10 gig port. Okay. And I do have diversity available in this data center. You'll see that Megaport offers a few different levels of pricing. 600 is month to month, 500 is 12 month, 24 months is 475, and 36 months. So I can term those ports if I want to, but I want it to be diverse from the existing port that I created. So I'm going to choose create diverse port and diverse from CO test LA. So let's do Ramco CO. Okay. Keep our naming schema similar. Go ahead and click next. We'll go ahead and add that port, and it'll move it to the shopping cart on the right-hand side, or left-hand side, excuse me. And so now I've got a red and a blue port ready for my services so that I can stand up diverse connection to the cloud or to another data center. Now, there's a few different ways that I can connect a port to a service, as I was alluding to, with a VXC. And when we do that, we can actually do this option here, plus connection, and that allows me to have these destination types. Cloud is what you would expect: Google, Azure, AWS, Oracle. Private VXC means I can connect to another Megaport on my network. Internet is actually a newer offering that you can actually stand up a Megaport connection directly from your port. It provisions a single IP address, and you can go up to 10 gig in terms of your internet bandwidth. All right. Let me go back. All right. I can go to the Internet Exchange, which is the global peering that we have, as I was alluding to, around the globe. And then this is the Megaport Marketplace, where I can actually go in and connect to a Megaport vendor that is published on our website. Most of them are public, but several of them are actually private that you can reach out to if you need to. But like, let's say, for example, I wanted to connect to Cloudflare in the security space. Well, what I could do is filter by the United States. And let's say I wanted to connect in Los Angeles because that's close to where my port lives. Well, I can grab the Cloudflare port in Los Angeles, give it a name, and initiate that request. And that'll generate a request to Cloudflare. They'll respond with a service key, and then I can go ahead and build that port, and then I'm connected to Cloudflare. Okay. Now, with the service key in mind, I want to show one other type of connection here. So I created a service key in advance for this, and it's right here. So I created this, and what I can do is actually allow a company to connect to my port who is also in Megaport. Where we see this example is, let's say I acquire a company called Elko, and Elko is also on Megaport, and I want to connect our environments together to share resources or get to their cloud environment. Well, I can do that very easily, and I can copy this to the clipboard. And then what I can do is that gives Elko permission to connect to my network. And so then I come into the Elko instance of Megaport. I go into plus connection. I enter the service key. And then that gives me that connection to get to Ramco, which I'm going to go ahead and make as 50 meg. And you can see that's also month to month and term pricing. And then that, when I do that, that builds a private connection, a layer 2 VLAN between myself and Ramco for the duration that I need it, however long I set up that service key for. But this is great in an acquisition or even a temporary data migration scenario. We see that quite a bit. So now let's look at connecting Elko to the cloud, and let's use an express route as an example, because I've already spoken to that in the diversity requirement. I'm going to pick cloud, and I'm going to toggle down here, and I'm going to pick Azure. Well, as it turns out, when you create an express route, you need to start it in Microsoft first. So I'm just going to show you what that looks like really quick, and then we'll build out the rest of this. So I've already built out this express route in Denver, getting to my US West 2 compute region and on-ramping in Denver. But I want to show you what that looks like from the beginning and build it out so you can see what I'm going to do with this. So let's go ahead and build an express route. I'm going to create it. The first thing I need to do is choose my resource group. I'm going to choose West US 2 as an example. Okay. This is where my compute lives. This is where the actual computing resources live. The circuit name is going to be a test ER2. Okay. And the provider is going to be Megaport. So this is where I choose Megaport as a partner provider to get to the express route service using a shared NNI, which are pre-built all over the globe. And I'm going to on-ramp in Denver. So what that means is I can get to any Azure cloud region once I on-ramp. So I'm going to leave the Megaport backbone in Denver and hop on Azure backbone there. And I'm going to do it at a speed of 50 meg. All right. So then I review and create that service, and I'm good to go. All right. I just wanted to walk you through what that looks like, and just so you would have a sense of it. So since I've got this express route built, I'm going to go ahead and go back into it. And I'm going to grab this service key right here. And so this is the pre-work I do in the Azure portal before I get to Megaport. So I have to have this already. So it's Denver on-ramp with a 50 meg connection going to US West 2 using Megaport. Going to copy the service key. Going to go back to the Megaport connection. From my port, I'm going to configure the first part of my express route, which is this Azure service key. And it's going to validate this here in just a bit. And remember, I said that Azure wants you to have 2 VXCs to satisfy their SLA going to 2 different routers. So I'm going to choose the first one at core site in Denver. I'm going to just go month to month. We're going to do ER primary. US West 2. Okay. And we're going to go ahead and assign that a VLAN of 200. We're going to go month to month. We are going to go ahead and assign a single peering VLAN. We're going to make that 100 for the Azure side. going to go ahead and provision that and add a VXC. Right? It's going to move it to the shopping cart. I haven't ordered it yet. Then I want to go in and I want to add a second one, my backup, to satisfy my SLA. So I'm going to go back to Plus Connection. I'm going to go to Cloud. I'm going to go to Azure. And then I'm going to drop back in that service key. And this time I'm going to choose the second one. I'm going to choose blue. And it's going to be ER2. Okay. And I'm going to make this VLAN 201 on the customer side. Going to go month to month on my term. And on the Azure side, I'm going to choose the same VLAN. We're going to convert that to the same VLAN on the Azure side. We're going to add the VXV. Okay. And then I can go ahead and click order, and all of those services will be provisioned, and it will push them into this area in the Azure portal. And when that's configured, and that's going to do this on the back end, then I'll be able to go in and configure my addressing information. So I'll put in the AS number, my IP addressing, the VLAN ID of 100 that I put in on the Azure side, and that connection's up and working. So with that in mind, I am going to stop sharing and pause because we're almost out of time. We went quickly through quite a bit of content. I hope it was helpful for you. I'm not seeing any questions in the chat at this point, but if you are interested, we hope you'll reach out, and we would love to have more conversations with you. If you're an existing customer or a new customer, we'd love to talk about your situation and how Megaport can become a vendor of trust for you. So thanks, and have a great day.